Dobrý den. Good morning, everyone. My name's David Hearnden. I'm an engineer on the Wave team. And I primarily work on the Wave client. And today, I'm going to be talking about the experience we've had in building the whole Wave client using the Google Web Toolkit. In particular, how valuable GWT has been for making the Wave client what it is. And if there's one thing that you take away from this talk, I hope it's that you realize how much the Wave team loves the Google Web Toolkit. So I'll start off by talking about the decision to use the Google Web Toolkit, some of our initial apprehensions, and then once we decided to use GWT, the resulting architecture that GWT allowed us to have. And then most of this talk will be about recent changes since the last 12 months in the Google Web Toolkit that have really allowed us to put the icing on the cake and turn the Wave client into a real full-fledged web application. Towards the end of the talk, I'll touch on some other changes we made and other efforts we made to make the Wave client to give the best user experience that we could provide. Improvements made to gears, plus some performance tweaks that we do, as well as talking about our mobile effort. And finally, I'll talk about our approach to testing, including a tool called Webdriver. So by now, you saw the Wave client in the demo this morning. And how many of you have used the Wave client or have Wave accounts already? Oh, quite a lot, that's good. So before we built the client, there were a number of design principles and philosophies that we knew this web application had to have. It had to be fast, it had to be stunning, it had to be something new. Most importantly, we needed to think beyond the browser, beyond what a browser could do late 2007. Another important part of the Wave client that occurs in many places is an optimistic UI, which means when you do an action in the Wave client, we show you the result of your action without waiting for a round trip to a server. So you can open a Wave, write your own message, submit, done, move to the next wave, and you don't have to wait for anything. Everything gets queued up, it gets sent to the server in the background, and we show you the result of what your actions, show you the result of your actions before waiting for acknowledgements. As much as possible, we want you not to wait anywhere in the application. So there's a few things I'd like to demonstrate which you may or may not have played with already. One of the first parts is thinking beyond the browser. So as you can see, the Wave client is a paneled environment, and these panels, just like a desktop application, like a windowing environment, they're resizable, they're movable, they're draggable. You can minimize them, maximize them. So that's an example of thinking beyond the browser, as well as our own customized scrolling mechanism. To do this without the Google Web Toolkit, to do this directly in JavaScript, would have been much, much harder. An example of the optimism I was talking about is you can see, as I type, you can see characters. As I type them, you can see the titles in the menu bars updating. You can see this thing here called the digest of the Wave. You can see it updates instantly. You can see the last modified time, the message count. All the information displayed to you is optimistic. And again, GWT really makes this possible for us. So most of you would have heard the previous talk, which described GWT already, but for those of you who weren't here, the Google Web Toolkit allows you to write your web application in Java. And then the GWT compiler compiles it into JavaScript and builds an Ajax web application for you. So the fact that you write in Java means you get the advantage of the vast array of development tools that Java has. It's much easier to develop in Java than JavaScript today. As well as being a richer development environment, the fact that you write in Java means that you can share the same code in the browser as running on a server. So there are many cases where this is a big advantage, but in particular in Google Wave's case, the underlying mechanism of a wave relies on these operations that get transmitted between the client and the server. And these operations go through what's called concurrency control. And transformations are applied to these operations to ensure that with live typing in every client, everyone eventually converges to the same state. This mechanism, it is vital, it is very important that all agents in the system run exactly the same logic. And the fact that we have the same code, like the same characters, like the same text in Java files running in the server as we do in all the clients, means that we get this reliability for free. We don't have to maintain a Java version and a JavaScript version of these transformation algorithms and just hope that they work identically. So the third big win of using Google Web Toolkit is GWT has a first-class mechanism called Deferred Binding. And this really lets you manage the complexity. In web applications, there are lots of dimensions for various configuration. What browser you're running in, what locale you're in, whether or not Gears is installed, what operating system you're on. All these different variants, you might need to do things slightly differently. And GWT uses this mechanism called Deferred Binding, and I'll show some examples of it later, that let you manage working in this very rich environment. And lastly, although you write almost everything in Java, you have as much access into JavaScript as you want. GWT gives you what's called the JavaScript native interface. This means you can write whatever you want in JavaScript and expose it to your application as Java native methods. So you don't need to worry about any control being taken away from you. If you think you can do something better than the GWT compiler, or you want access to particular JavaScript objects, or call particular JavaScript functions that aren't exposed in Java, then you can do all that as much as you want. So GWT had a lot of selling points. And in late 2007, when the decision was made to turn Google Wave into like a real application, at that stage it was just a hacked up prototype. When the decision was made to put in a real engineering effort and make it a real application, there was a bit of apprehension to using the Google Web Toolkit. Many of the engineers came from working on Google Maps. And Google Maps, as you know, is all in JavaScript. And JavaScript is a great language for web development. But Google Web Toolkit did look very appealing. But there was a list of things that GWT couldn't do at that time. And to do a real web application and make it a first class in quality, we really needed a few extra things on top. And that's what the rest of this talk will be about. But the main reason that we chose to use Google Web Toolkit, and I hope many of you choose to do this as well, is that it lets you operate at a higher level of abstraction. You don't worry so much about limitations of the browser. You can concentrate more on what kind of user experience you want to give your users. And you have as much control over writing your own interfaces, your own levels of abstraction as you like. As you saw, we implemented our own scroll bars, our own panel management, our own windowing system within the browser. And this is all because GWT lets us move out of thinking about browser limitations. So there are a number of parts of the Google Wave client that these parts of GWT have really enabled. Inside the Google Wave client, we actually run our own multitasking environment. We have our own scheduler, our own priority queue for running commands, and all this is possible because we're not tied to thinking about what browsers can do. Within this scheduler, it's very important to be able to get control back to the browser to do rendering and to handle UI events, and then come back into the JavaScript to keep running computation. And just as a piece of trivia, if you use the JavaScript methods of set timeout and set interval, the fastest you can get control back into your code is about 10 to 15 milliseconds. But what the people on the GWT team have been working on is using completely different mechanisms of passing control back to the browser and then back into your JavaScript. There's some really beautiful hacks in there, but the point is we don't worry about how it works. And GWT lets us get deferred commands coming back in 5 to 6 milliseconds, which if you're running in a scheduler environment where you want to be yielding to the browser and getting control back as quickly as possible, the difference between 5 milliseconds and 15 milliseconds is quite significant. But we don't have to worry about how it works. GWT does it all and handles the browser quirks for us. I talked about how GWT lets you share code on the client and server. And this is fundamental to our communication infrastructure in the Wave client. The client and the server communicate in just plain messages, and these are JSON strings. The structure of these messages is described by what are called protocol buffers. And this is some technology Google open sourced, I think, earlier this year or late last year. Essentially, it's just structured messages. And these protocol buffers describe the structure of these messages. And the protocol buffer tools generate Java implementations and generate Java interfaces that you can program against. Now, in GWT, in our client, we have our own custom client implementations of these messages. But because they implement Java interfaces, we can have the same code on the client and the server processing these messages. We don't have to write that code twice. So on top of this communication stack, we have waves. Waves running in memory. Waves essentially contain rich documents. And on top of these documents, we have our own domain models to build conversations, to build catalog information, to build spell correction information, attachments, your own personal user data. Lots of things are built on top of these waves, and it's all the same code running in the servers, running in the browser. The code sharing aspect of GWT is not to be underestimated. It is a huge win. And then aside from waves, we have our own library of widgets. And GWT allows us to write these widgets as self-contained components that we can plug together. And I'll talk more about how we plug them together and what goes into building these widgets in later slides. So right now, this Wave client that we've built with GWT, we support all the modern browsers, Safari, Chrome, Firefox 3. We support IE using Chrome Frame. We are working on a native IE7 and IE8 version of Wave, as well as mobile devices, Android and iPhone. GWT gives us mobile implementations and an IE7 implementation for free, but we do need to do some work to make them perform better. But 90% of the work is already done, just because we use GWT. GWT actually supports more browsers than this, but we limit it at this because these are the only ones we're currently committed to supporting. So now I'll talk about the icing on the cake. When we started the project in late 2007, building this client for real, GWT could give us cake without icing. And if you're in the business of serving cake, you can't serve cake without icing. Cake is great. It takes a lot of effort to make cake, but you need the icing on top. I'm going to talk about 7 things which really turn an okay web application into something real. So the main things I'll talk about are how you go about writing the UI code itself, how you deal with cross-browser CSS, how you deal with JSON messages, how you debug. And you might have seen some of this in the keynote this morning and in the GWT presentation before this one. And also how you deal with the fact that GWT runs in a monolithic compile framework. It builds one application out of all your code, and it's one chunk. There it is. Download it all in one go. That's how GWT used to be. So first up, I'll talk about how you actually create the UI. And in late 2007, this is what the code looked like. And you might have seen code like this in the example this morning. So this is great for people familiar with existing Java widget toolkits, like Swing or like SWT. It's very familiar. It's very easy to follow what's going on. But it is time-consuming to write a UI like this. And it's also not clear what the resulting HTML is going to be and what the resulting CSS is that applies to this widget. So although GWT made it very easy to write UI code like this, we wanted something better. What you do now is they have a tool called UI Binder. It was previously known as declarative UI to those who might have used it before. And now the way you write widgets in GWT is declaratively. You write a template, an XML fragment, which contains the HTML that you want your widget to look like. And you annotate, you decorate this HTML with particular attributes and particular properties that tell UI Binder how to glue up this HTML fragment with variables and with fields in your Java code. So this makes the code not only simpler, smaller, easier to read, faster to write, it also means that UI designers who are more likely to be familiar with HTML and JavaScript and CSS than with Java. UI designers can come in and modify these widget templates directly to get the look that they want. They don't need to come and poke the Java programmers and say, can you change whatever your widgets do to make it look like this instead? So the next part of this declarative story is how you deal with CSS. GWT does a fantastic job of abstracting the behavioral quirks of browsers away when dealing with browser events or running JavaScript. But when it comes to rendering and layout and how browsers interpret the CSS specification, they're all different. So there's not really any solution other than allowing you to control how your CSS, getting different bits of CSS to apply in different browsers and to present it in a way where you can wrap your head around what's going on. Initially, the Wave client had one CSS file. It was about 4,000 lines. No one knew how it worked. Like, rules were conflicting with each other. It was, anyone who's dealt with CSS knows 4,000 lines is just completely unmanageable. So in GWT, there's now a tool called Style Injector. And what Style Injector does is, along with your little individual widget components, you write just the CSS that applies to that component. And then the GWT compiler, through Style Injector, actually compiles your CSS rules into your JavaScript. And this gives you lots of benefits. For a start, it gives you static verification that your rules are actually doing something. You haven't misspelled a class name. You don't have rules that aren't applying to anything. So you get a lot of static verification, which catches many, many CSS bugs. The second thing is because this CSS is processed, it's compiled, you can use big, long, descriptive class names to keep your CSS manageable. And Style Injector will replace those class names with very short strings, like just single or double or triple letters. This not only it makes the DOM smaller, it makes the rules smaller, so it's faster for the browser to parse, faster for the browser to apply. And finally, this is one way you can use deferred binding, is within your CSS rules, you can deal with browser quirks by having little custom fragments for different browsers. So this example here is just a snippet of a CSS file for a particular widget that just applies an extra rule when running on Safari. And you can see it's a little if user agent on Safari, apply this extra rule. And the GWT compiler compiles this out for non-Safari browsers and compiles it in for Safari and WebKit. And it actually does some CSS optimization. It will take a bunch of rules, it will collapse them together, it will rearrange your rules, it will do some pretty fancy stuff, and you don't need to worry about it. You can keep everything nice, simple, and declarative. So the third part that was missing was, like I said, we wanted to use JSON as our communication format. And passing strings between the client and server was very simple. But at that time, to process a JSON message was quite heavyweight in GWT. When you run a GWT application, there's a universe of objects created by your application. And you can call these Java objects. Everything else, all the native JavaScript objects, to get access to them in your Java application, at that time meant traversing these objects, creating parallel structures, and it was quite inefficient. So what you do now is some wonderful compiler magic called overlay types. And you don't need to worry about the name. All you do is take a special class called JavaScript object. And this is a signal to the GWT compiler that this class is special. This class is used to describe a native JavaScript object that you don't create, you just get access to somehow. So this means you can take native JavaScript objects like incoming messages, browser events, the DOM, and you can access it directly in your Java code. But the big win is that all these accesses completely inline away in the GWT compiler. The result is absolutely zero overhead. There's no copying, there's no forwarding, there's no like the odd method call in front. It's direct property accesses in the JavaScript. But in Java, it's still described nicely all as Java classes. So this in particular meant we could use JSON messages for communication with zero overhead cost. It will be just as efficient if we wrote it by hand in JavaScript ourselves. So our next part is how to debug your web application. Given that each browser has its own quirks. So many of you will be familiar with using Firebug, and we all love Firebug. It's very powerful. But if you've got a particular bug on IE or on Safari, what do? You have to use the IE developer toolbar or IE developer tools for IE. You have to use the WebKit tools for Safari. So this wasn't so productive for us. And then GWT came along with what's called out-of-process hosted mode. So at the time, the GWT debugging environment was a hosted browser based on Mozilla, and you could set breakpoints, you could change the code, refresh, and that was all fine for debugging things that behaved like Mozilla. But now you can debug natively in IE, in Safari, and in Firefox, and as you saw this morning, the code actually runs in the real browser. So I'll give a quick demo, given that I know many of you would have seen this already, but it really is quite some magic. So what I have here is a development setup. I've got Firefox 3 running here, and it's the Wave client. And you can see it's live and functional. I can move around, resize. I can open waves. Now this code is running in a Java VM, in Eclipse. And what that means I can do is I can set breakpoints, I can change the code. For example, what do I want to change? Sorry, this is going over wireless over a few countries. This guy. So I can set breakpoints, I can change the code. I'm not going to change the code, I'm just going to set a breakpoint because you would have already seen this code running this morning. This is what I want to do. So for example, if you were tracking down some bug with handling your key events, this is real Wave code. This is what is running when you're using the Wave client and you're using keyboard shortcuts. This is the code. So I can set a breakpoint here for processing the down and tab key. I can go back to the browser. This is real Firefox running magic JavaScript. When I hit the down key, I hit the breakpoint, and I'm here. I can continue, I can step through. You see, I can step through and do all the kind of stuff you can do in Java debugging. And I can do this in Firefox, IE, Safari, and it's all running exactly the way the browser would behave. So that blew me away first time I saw that. It's really quite some sophisticated stuff that's going on there. So that's the improvements to the debugging story in GWT. The next part is how you deal with a big real web application. So this graph you see here plots the size of the initial download of the Wave client over time. And this graph cuts off around May this year. So at that time, our download size was growing and growing. We were adding more and more features. But every feature we added, no matter how obscure it was getting downloaded for everyone. So we crossed over 1 megabyte for the initial download, and we thought, this isn't so good. Then the GWT team came along and said, this is what you do. There's a magic GWT method called run async. What run async does is your entire application is one big bundle of code. Run async is a signal to the GWT compiler to put in cut points in your code. And using those cut points, the GWT compiler can figure out what are called islands of code. And it can figure out the dependencies between these islands. And it can generate separate JavaScript for each of these islands. And the control flow from one island into the next is lazily loaded. So the initial download, the only stuff that comes down is what you use. And other parts of the application only get downloaded as the user does something that invokes that part of the application. This goes not just for code, but for resources like images, CSS, and HTML fragments. And all this magic is done by the GWT compiler for free. All you need to do is be smart about figuring out where to put the cut points and how to carve up your application into these independent islands. So after we started doing this, you can see our initial download size fell dramatically. I think if you look at the numbers, from the top of the peak, it was about 1.2 megabytes. And after applying run async to some key places, we got the download size down to about, I think it was under 200K. I think it was about 230K, which is a huge difference in speed for the initial startup. So along with reducing the amount of code that you download in the first fragment, it was also very important to know where all the JavaScript goes. You have a big application, it's all in Java. You get some sense of what are the big packages, but you don't really know what it looks like when it compiles into JavaScript. So the GWT compiler can now output what's called the story of your compile. And what this does is it tells you where all the JavaScript is coming from. So for example, this is the story of your compile report on the Wave client from 2 hours ago, I think. So you can see, can I make this bigger? So I hope you can see some of those numbers. So the whole client is just under 2.5 megabytes at the moment, before gzip. But in the initial download, you only download about 30% of it, about 800K. The rest of it is all behind these run async points. And if we go into any of those points, like this first one, the story of your compile report tells you, it breaks down all the Java packages and says that 85 kilobytes of JavaScript is coming from the Wave panel package, and 53 kilobytes of JavaScript, which is quite a lot of code, is coming from the model conversation package. So this lets you have smart optimization about focusing effort on addressing the big parts of your code with very accurate measurements. So based on the story of your compile reports, we come up to both story of your compile reports and this particular issue combined let us halve the size of our initial download again. So I mentioned JavaScript object before as a special class that lets you fold in native JavaScript objects into your Java universe. So at the time that this was introduced, this particular magic worked, and still it works by devirtualizing all accesses to these JavaScript objects. So this means that every method call on one of these objects must be statically identifiable as a JavaScript object. So at the time, the way to guarantee this was JavaScript objects just can't implement any interfaces, because an interface implies polymorphic dispatch. It implies virtual method calls. But this really threw a spanner in the works for our message infrastructure, where we wanted to use JSON messages and use these protocol buffers I described before, which give Java interfaces for free. And these Java interfaces let us share code on the client and server for processing these messages. So we knew that to get efficient implementations of processing the incoming JSON, we needed JSOs, but we also needed them to implement interfaces so that we could share code on client and server. So GWT lets you do this now with a magic annotation called single JSO impl. And this means that you can take an interface and say, this interface can be implemented by just this JavaScript object class, which means that the GWT compiler, when it sees something that is of that type, knows that it is in the client code, it is really one of these JavaScript objects, and it can continue to devirtualize everything and get all the static inlining that makes JavaScript objects work. It sounds a little confusing, but the big win is that you can share code on the client and server and have very efficient implementations in the client based on JavaScript object. So when we put those two together, the story of your compile reports and the single JSO impl, we identified that the message infrastructure, just all these message classes that we were using for communication, was contributing to half of our 300K initial download. like an entire 150K was coming from just all these messages, all these message classes, just naming all their fields, providing different classes for every different type of message. And once we implemented them using JSOs and used single JSO impl to expose them as these protocol buffer interfaces, our code size dropped by 50% in the initial download, which was a huge win. So just in summary, the GWT changes in the last 18 months that really mean you can build complete, proper, fully fledged web applications like the Wave client using a declarative way to specify your widgets using UI Binder, using Style Injector to deal with CSS, especially cross-browser CSS quirks, using the JavaScript object class to get very efficient access into JavaScript objects, out-of-process hosted mode for debugging in each browser as close to natively as is possible, run async for carving up your application into different islands of code that then get downloaded on the fly, store of your compiler reports for identifying where your JavaScript is coming from, and finally, single JSO impl for exposing your very efficient JavaScript object classes as interfaces so you can share code on client and server. So that ends the in-depth technical part of the talk. For the rest of the talk, I'm going to touch briefly on some changes we made to improve the overall experience, and I'll finish up by talking about testing. So as you saw in the demo this morning, the way we deal with images is you can drag them straight from your desktop onto your browser, and that's it. Wave does the rest in collaboration with Gears. So we added desktop drag and drop support to Gears. So adding attachments and adding images is as native as you would find using a desktop application. So this all comes back to thinking outside the browser and using GWT to get at a high level of abstraction so we don't find ourselves being constrained by what browsers can do today. And a final point is resumable uploading of attachments. So if you drag and drop a bunch of images into the Wave client, you can then close your browser while it's uploading and then do some other stuff, come back. When you come back into Wave, through Gears, those uploads will just start continuing automatically. So we made another bunch of improvements just for all-round performance benefits. The first came from aggressively using run async to reduce our initial download size. When we first started that particular effort, we got our initial download size to about 150K, which this is pre-gzip. Right now it's crept back up to a few hundred K, but if we were to repeat the process, we could carve it down and make the initial download really small again. Another thing we do is, as you saw when you start up the Wave client, there are particular services that your client invokes. It gets your catalog information, and importantly, it gets your inbox query to find all the waves in your inbox. So rather than waiting for your client to load and then your client issuing these RPCs to our servers, instead, when you load the client, we run those queries before the code even hits your browser. And along with the initial page that comes down into your browser, we include the results of those queries. And this we call fast start. And the results of these queries are just attached to the window object, and using the JavaScript object class again that GWT lets us use, we get access to these sort of pre-rendered results, and we fake the initial RPC response so that you get as much of the client starting up in the initial Another benefit of using the style injector tool within GWT is how it deals with images. So as you know, there's a 2-connection limit that browsers have to a particular domain. So if you're downloading 20 images for all these different sprites you might have on your application, having a 2-connection limit really, you pay a severe performance penalty in terms of latency from when you start downloading these images until they're all finished. Style Injector does 2 things that make this problem go away completely. First of all, it actually compiles your images into the CSS using data URLs. So if you, in fact, I can show you in the web client, if you look at any of our sprites, you'll see they don't refer to images. So for example, there's going to be something in here. So something I mentioned before was the minification of class names. So if you look in the Wave client, you see all the CSS class names are very short strings. In the source code, they're big, rich, descriptive names, but GWT compiles them down for us. And if I can just find one that has an image. So I don't know what that element is pointing to, but it has a background. And normally you might refer to a URL as an HTTP URL referring to an image. But Style Injector compiles that image into, I think it's base 64, and the image is there inside the CSS rules, which means that all these images, there's no fetching. They're part of the CSS. They're part of your code, essentially. So that's one thing Style Injector does. And so this trick only works on browsers that support data URLs. And for browsers that don't support data URLs, what Style Injector can do is take all your images, and you might have hundreds of very fine-grained images for different sprites, combines them all into one big image. So there's just one download. And it generates the CSS rules to extract out the different images and apply just your little images to particular elements. So again, this just happens for you for free. You don't have to do anything special. So like I said, we use run async to reduce the initial download. We do some fairly aggressive stats collection for how long it takes you to open waves, how long it takes for the client to start up, how long it takes to do searches, and we're constantly monitoring the performance of these statistics that we're collecting. So you can see in our own graphs, these are coming down slowly over time. And there's many more things that we're collecting stats for, but we are very focused. We're very focused on improving the performance, and we have real statistics backing this up. And a last little tweak we made is the normal way of starting up a GWT application is it runs a small amount of JavaScript to sniff around your browser and figure out what browser you're in, what operating system, what locale, whether or not you've got gears, and it uses that information to pick which version of the application to download for you. So this is great, it's simple, you don't have to worry about it, but it does mean 2 round trips when someone just wants to start up your application. So on Wave, we've shifted this logic into our servers. So based on your initial HTTP request, we figure out this for you, and we select which version of the application on the server side. So this saves you a round trip when you first start up the client. And once the client is running, you saw some of the examples of an optimistic UI, where you don't have to wait for anything, where we can show you a predictable result. We also do fairly aggressive prefetching. So whenever you do a search, inbox is probably good. Whenever you do a search, all your search results that come back, we start fetching those waves straight away, so that by the time you go to click on something, that wave is largely already there loaded. so we can show it to you as quickly as possible. And the last two things that we've focused on for improving performance are we've got a lot of value of using the flyweight pattern and pooling widgets. So many of you might have found this yourself, but reusing DOM versus creating more DOM is significantly and measurably faster. So any of you using intensive UIs, we encourage you to take your widgets and make them reusable and keep them in a pool so that when you need to display more ones, you just pull them out and repurpose them. This is at least twice as fast as creating fresh new widgets. And the last point is GWT has its own widget library. You saw in the code samples, you can create panels, labels, text boxes. All these things are part of a widget library. And this is great for getting you going. It's very easy to write UI code this way. But this library is relatively expensive in terms of performance. So after this library came out, GWT released a set of APIs for interacting directly with the DOM using the JavaScript object trick. So code written like that is much faster than using GWT widgets. So if you can just use the DOM directly, we recommend you use the GWT DOM APIs rather than using GWT widgets. And lastly, we don't have a very dedicated effort on mobile, largely because GWT gives us an application essentially for free. So I can show you, we officially don't support mobile devices yet. If you try and load the Wave client on your Android or on your iPhone, it'll say browser not supported, but you can click through and use it anyway. And what you see is something like this. It's essentially the same code that runs on the desktop client, just a few things stripped out, and GWT takes care of the rest. So you can see I've got waves. I can search through them. I can open waves. And you can scroll through and read them. At the moment, it's passable for reading waves. Interacting with waves and writing replies is not really a very good experience yet. So we're not recommending that you use the client yet on mobile devices. But the code is all there and it all works. And if we had to start a mobile client effort from scratch, writing it in Objective-C or freshly in Java again, it would be a huge amount of work. But we've essentially done, we make the joke that our mobile effort is the left hand of one of our engineers. And with just that left hand and the power of GWT, we get a mobile client for free. So we have done some improvements and made some specific optimizations for the mobile client, which have, at one stage we had a goal to make the mobile client load in under 60 seconds. Because at the time it was taking about 3 minutes to load. We got it down to under 60 seconds. It's now down to 10 seconds. Maybe we'll get it down to 2 or 3 seconds. But a lot of this comes from using the techniques and using the recent tools like run async and store of your compile to figure out what's going on. It's unlikely at the moment that we'll have a native mobile client written, but all our APIs are there. So if any of you would like to try it, we'd thoroughly recommend that you give it a try. So, but just a piece of trivia is that on the iPhone browser is always running, which means web applications start up much faster than native applications. So for a bunch of reasons, we're probably just going to continue with the GWT-generated mobile client. We have slightly optimized the communication channel that we use for passing around messages. I didn't mention this earlier, but our communication channel, it's a Comet-style channel where we have a bidirectional communication stream with the server. It's based on a hanging get. And we made a few tweaks for mobile. We've put in some work on making it ready for HTML5, in particular app caching. And I've shown you the iPhone demo. So the last thing I'm going to talk about is what we do with testing on the Wave client. So GWT gives you a test environment where you can run your code in JavaScript in a mocked browser. And these are called GWT test cases. They're just like JUnit test cases. You write your test methods, and the test framework just runs them. And in a GWT test case, these are compiled into JavaScript, which means you do have to pay the cost of a compilation step. So this is great, and it's very good for testing your code in an automated way, running in a real JavaScript context, but they are quite slow. So as much as possible, we've tried to use JUnit tests and plain regular Java testing to test as much code as possible. And the model view presenter pattern really makes this possible. So we tried model view controller, but we found model view presenter. We got much more mileage out of it. So we thoroughly recommend you look at that pattern if you don't already use it. And so that covers unit tests. There's another tool which I mentioned at the start called Webdriver. And Webdriver is what we use for testing in an automated way someone interacting with the browser. So what Webdriver does is it starts up a real browser, points it to a URL, and it simulates at the operating system level. It simulates click events, key events, and interacting with the DOM. So the code, so I'll just run Webdriver here, and what you'll see is a little terminal come up. In a second, you'll see Firefox start up. And you'll just see magic ghost typing and clicking occurring. And that's the Webdriver test. It's going to load the client. It's going to create a new wave and type around in it. Let me just see. Yep, it's starting up. There we go. So you can see it's logging into Google Wave. It's typing in an account. And up comes the Wave client. You'll see it'll create a new wave, it'll type some replies, move around in it. Underneath, the test is checking that the reply structure is coming out fine, the title is getting extracted, the replies are going in the right place. And all this is completely automated. And the code that is running is just our client. It's not synthesized, it's not instrumented or harnessed in any way, it's just running against the plain client you would use in your browser. So we watch these tests run all day, and we've got loads and loads of them. But Webdriver is really a phenomenal tool. We recommend you check it out. So yeah, like I said, the big advantage with Webdriver is that it, just to reiterate, it uses native keyboard and mouse events. So it tests your code in a real environment. And Google Wave is as committed to Webdriver as we are to GWT. We've extracted so much value out of using Webdriver. We couldn't have done the client without it. So if you choose to use Webdriver for your own development, the way you structure your code, it's, again, just like unit tests. You write test methods, and here's a snippet of one of our Webdriver tests. And we recommend that for each widget and for each UI component in your application, you write a little test helper class that exposes the kind of actions that a user can perform on that. So that allows you to write your tests in a literate style. So it makes the code read intentionally. So for example, this test goes to a wave panel, goes to a focused blip, goes to the editor, types some text, hits enter, types more text. The test checks what the resulting structure of the editor is, including all the formatting. Clicking submit, it tests that the title gets extracted and so on. So we recommend that's how you style your tests. And the mode in which these tests run is you perform some actions, and then you inspect the DOM and check that the DOM turned out the way it should if your application is running correctly. And the way you access the DOM is through a series of locators. There's the ability to access things using XPath. And XPath essentially will give you access to anything. But XPath is quite slow running in WebDriver. So pretty much anything else, you can use IDs, you can use local navigation around the DOM, and you can use attribute names. They all give you much faster access into the DOM, and your tests run much faster. So that concludes the talk. In summary, I talked about the initial decision of whether or not to build the Wave client using GWT. I talked about what we needed the Wave client to be and what we needed from GWT in order to do it. And not everything was there at the time. Now it is. And I talked about the way we can build the client now and the recent changes in GWT that really put the icing on the cake for us. And then I just touched up on a random collection of things that we've done to improve the overall experience, including performance, touched on our mobile effort, and finally our approach to testing. And that concludes the talk. There's a bunch of links there. If you want to learn more about Wave or Google Web Toolkit or WebDriver, you can follow those links or you can ask questions. Thank you for your attention.